All right, on to the next installment. Now, our big term. See if I can get some more room to work. Our big term to understand here, as we're trying to build pieces together, is this idea of a reference angle. If we are in some generic triangular case, right? Our reference angle will always be the angle that is touching the x-axis and the side that's not vertical, so the hypotenuse, right? So there would be a reference angle if we'd have a triangle in quadrant 2. Remember that this quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? The reference angle touches the x-axis and not next to the vertical side. So it's made up with at the origin and touching the x-axis. In quadrant 3, the reference angle is right there. In quadrant 4, the reference angle is right there. So we got a little bow tie going on. Now let's see what this looks like to find in practice. So first challenge right out of the bat, I tell you what, let's start with degrees just because I imagine that most of you are more comfortable in degrees. And then we'll come back to some of the radian problems. Here's 0. Let's get a little thinner line here. Here's 90. Here's 180. Here's 270. And then 360 again, of course. Right? So 210 is clearly in here somewhere. Right? What we want to do is wherever it's at once we draw this, right? So we went from here all the way to here, right? We want to go from here and go straight perpendicular back to the x-axis. So now our reference triangle is here, and our reference angle is touching the x-axis and touching the origin, right? So it's there. So now that we've identified where it's at, let's identify what it is. So if you imagine with 210, if we go all the way here into a semicircle, we've just used up 180, right? So if we go 210 minus 180, we're left with 30, which means our additional 30 is right here, right? So our reference angle, what we're trying to find, is equal to 30 degrees. This is the answer we're looking to produce. We're going to do a lot of calculations off that 30 degrees. Let's do a few more degree problems before we move to radians. 0, 90, 180, 270, and of course back to 360. So now our challenge is we threw this negative in here, right? So when we travel from here to here, that's negative 90 degrees, right? We just traveled negative 90. We're going to get to negative 130, which means we need to keep going. We're not going to go all the way over to the x-axis because then that would be negative 180. So somewhere in here is a negative 130. So again, we're going to draw straight perpendicular to the x-axis, and we're going to see this right triangle, right? Now, per definition, the reference angle is touching the x-axis and touching the origin. So our reference angle is right there. Reference angle. That's a little notation for angle if you don't remember from your geometry days. So let's imagine then our reference angle, something that you should know, will always be positive, right? So first of all, if we used up 90 degrees of this 130, this negative 130, we're left with 40, right? So this must be another negative 40 for a total of negative 130. Let's go ahead and think then, what is the space from this terminal side back to the x-axis. So if we've used up 130 here, if we wanted to keep going to a negative 180, it would take 50 more degrees, right? 130 plus 50 is 180. So our reference angle is positive 50. We will always use positive angles as reference angles. So let's try to squeeze in one more degree measure here. I'll have to erase some work, give us plenty of room. If you need that problem, you can go back on the video. So first, let's draw in all of our measures. And of course, 360. And let's start to reason where 260 is going to be out. So negative 90, negative 180. If we went all the way up another quadrant, we'd be at negative 270. So we know it's going to be somewhere in here that we're going to not reach 270, right? So following the process, we're going to drop it straight down, get our right triangle, get our reference angle to be the angle that's touching the x-axis and the origin. So we know that there's our reference angle right there. Reference angle. So now let's do some math to try to figure it out. So if we went 180, if we do 260 minus 180, oops, 5, well, that should be 0. 1, that was 7, right? Or 16, duh. So 8, so we need another 80 degrees. That means our reference angle, there's another 80 here. Again, we're going to report our reference angle as positive 80 degrees. All right, on to the big bad radians. Let's clear out some space for these. So whether you have to use your conversions that you would have learned in part 1 or not, I'm going to say, maybe I should, but that I know already that this is 0 if we're at 0 degrees or 0 radians. If we go all the way around the circle, we'd be at 2 pi. If we cut 2 pi a full circle all the way in half into a semicircle, we're at pi, 2 pi divided by 2. Then if we cut 180 in half, we're pi over 2. If we go pi over pi plus pi over 2, we're at 3 pi over 2. So these are like standard bearer. And you go far enough in mathematics, you eventually just memorize these. So now let's try to visualize where 5 pi over 3 is at compared to our axis. The biggest thing is I know that 5 pi over 3 is over 1 pi. So I know it's past quadrant 1 and it's not in quadrant 2. My question is whether it's in quadrant 3 or quadrant 4. So I need to be able to compare it to 3 pi over 2. So do an old school comparison problem with like inequalities. Try to find whether it's greater than, less than. Of course, it's hard when we're not common denominators. So if I take this one and multiply top and bottom by 3, I get 9 pi over 2, or over 6. And then if I take this one and multiply top and bottom by 2, I get 10 pi over 6. So now, to me, it's very clear that 10 is greater than 9, which means that my coterminal side is somewhere in here, right? If I drop it straight perpendicular to the x-axis, my reference angle will go here, right? Draw the line, reference angle. Now, how are we going to find out just what we got left? Well, I think the problem that I'm going to set up is 2 pi going all the way around the circle minus 5 pi over 3, because that'll take out from here all the way to here, and what's left will just make up the 2 pi. So if we multiply top and bottom here by 3 to get common denominators, we're at 6 pi over 3 minus 5 pi over 3. And what this does is tell us that our reference angle is going to be 1 pi, or just pi over 3. So our reference angle here is pi over 3, which I'm sure is very abstract in your mind because radians is a fairly new concept, but we need to be able to work in that. The challenge is generally like somebody not understanding the metric system and being able to visualize what a kilometer is versus being more comfortable with miles. That's a simple analogy in comparison to radians and degrees. So now let's see if we can go negative 0 and 2 pi, pi over 2, pi, 3 pi over 2. So negative 7 pi over 9 is not a full pi, right? So now the question is it in quadrant 4 or quadrant 3? The reason I ask those is because it's negative, so we're going to be traveling this way, some direction, right? So let's see, is negative 7 pi over 9, how does that compare to, now this seems really weird as well, right? But I'm not going to compare it to 3 pi over 2. I'm going to compare it to negative pi over 2, because if you imagine going 90 degrees in the opposite direction, this 3 pi over 2 is essentially equal to negative pi over 2, or this is equal to negative pi, or this is equal to negative 3 pi over 2 if we're going the opposite direction, or this is equal to negative 2 pi if we're going the opposite direction. Hit me up if that doesn't work for you mentally. So let's figure out which one's bigger. Common denominators times 2 over 2, so negative 14 pi over 18 versus times 9 over 9, which is negative 9 pi over 18, which means this is the bigger negative number, which means it's going to be in quadrant 3 somewhere. Now, what I really want to do is draw that straight perpendicular, making that 90 degrees. Now I have a reference triangle, which also means going for my reference angle. And my reference angle, let's get there. So let's imagine I want to travel a full negative pi. So from 0 all the way through to here, but instead I only made it to negative 7 pi over 9, and let's see how much I have left. So negative pi minus negative 7 pi over 9, and let's see. So if I multiply top and bottom by 9 over 9, I got negative 9 pi over 9 minus, or well, really plus 7 pi over 9. That gives me negative 2 pi over 9, which means here to here is negative 2 pi over 9 left over to keep going in the negative, but our reference angle is always positive, so we're going to call this 2 pi over 9. All right, some of you are starting to come in for first period class. I hope you stay a little bit silent so I can finish up this problem, and then we'll call it a video. You can always erase, or you can always rewind to try to find some of this back. I'm just cleaning it up so we can focus on this last problem. And here we go. Last problem, problem F. We're in radians, so 0 or 2 pi, pi over 2, pi, 3 pi over 2, back to 4 pi over 2, which is 2 pi. So let's figure out where 15 pi over 4 is. How many times does 15 or 4 go into 15? Well, 3 times, right? 3 times 4 is 12, which means this is 3 and 3/4 pi, right? Which means to me that this thing goes around the circle 1, 2, 3 times, and then we're still left with 3 pi over 4 as the thing that we're really trying to find a reference angle of, 3 pi over 4. So a real quick, easy thought here, trying to figure out whether it's in quadrant 1 or quadrant 2, is comparing it to pi over 2. So if pi over 2 is the same as 2 pi over 4, correct? So we know that this 3 pi over 4 is bigger than 2 pi over 4. So it must be in here somewhere. Drop the side straight down perpendicular. Reference angle touches the x-axis and the origin. So we need to find this reference angle right here. We need to find this reference angle right here. We've traveled 3 pi over 4 this way, and we need to get all the way to pi. So if we make pi 4 pi over 4, that's equal to this pi, and we subtract out 3 pi over 4, we are left with 1 pi over 4, or just pi over 4 in this angle. So our reference angle that we would calculate would be pi over 4. All right. This reference angle stuff is heavy business. So give it the time it deserves. Ask the questions that you need to ask of me in class to make sure we understand it. Sorry for the background noise.